Morning. In continuation with the previous lecture, we will be continuing with the next definition that we'll be using frequently in the digital fundamentals is the product term. So when this product term, it is considered a literal or a logical product of multiple literals is termed to be an product term. A literal or a ending of multiple literals. So examples that already we have seen x or xy, xy, z bar, etc. are the examples of the product terms. The next definition which we will be using in the digital fundamentals is the sum term. How do we define a sum term? A literal or the logical or of multiple literals is termed to be an sum term. Sum terms. So example, you can here say a literal. It can be in the form of a variable or its complement, or it may be the combination of literals. It may be one or two or three or more variables also, x bar, y bar, odd with z. Three variables have been odd, and such type of ORing of multiple sum terms, is multiple literals forming a term is termed to be the sum term. Coming to the next definition that we'll be often using is max term. What do you mean by max term means? It is a sum of, it is a sum term in a Boolean equation that represents always a condition in a truth table where the output is logical zero. Logical zero you can see in the truth table. In truth table, output function of a truth table. It is a logical OR of all literals of a function ANDed with other max terms. And another point that you should remember that any max term equation or max term, when it is considered, must contain all the variables, contain all input variables which are defining the functions. Example, suppose f is a function of x, y, z, three variables, and for which when the max term has been represented, it can be a literal of any variable ORing. So hence, the examples which we can represent for these three variables as x, y bar, z as one max term, ANDed with another max term also must contain all the variables or all the variables in the literal form. So this is an example for max term. Moving further, another term that we must know in our digital fundamentals is the min term. It is exactly the max term inversion. So hence it is a sum term. It is a AND term in a Boolean expression or in a Boolean equation that represents a condition in a truth table. Condition in output function of truth table as logical 0. Sorry, logical 1. Because there it is logical 0 and here it should be logical 1. Here also this is a min term definition. When multiple min terms we have, it is a logical and of all the literals of a function, and such multiple terms needs to be odd with other min terms in a switching equation. To illustrate this one, it is a logical and of. Any min term is a logical and of all literals of a function, and such multiple terms when we have in a given switching equation, such terms are odd with other min terms in a switching equation. How do an example will illustrate for this? For this, consider a output switching equation, output as f, which is a function of three variables x, y, z. When the min terms switching expression we are representing, all the min terms should have all the literals, three literals in our considered expression as x, y, z. So therefore, x bar ANDed with y, z. Between the literals, there should be an AND operation, and between such min terms, there should be an OR operation. So this illustrates an min term and min terms expression. The next definition that we must know is an canonical product of sums. In simple, we'll say this as POS representation. This canonical product of sums is a complete set of max terms combination. That defines all defines the output as 0 in truth table, and it is a logical ANDing of OR terms. The next definition that we should know is canonical sum of products. It is, in short, we'll say that SOP, form of expression. Here, before we go for that one in detail, let me give an example for this canonical product of sums as x plus x odd with y odd with z ANDed with x bar odd with y odd with z bar and so on. The canonical sum of products is the next definition, is a complete set of min terms that defines logical, that defines output in truth table as 1 and such many terms have to be odd. Logical ORing of min terms will represent the canonical SOP. Example here we have is that x, y, z odd with x, y bar, z odd with x, z bar, y. The last definition that we have to have is canonical form. What do you mean by canonical form? It is, by definition, it is conforming to rule. What this canonical form means? Each max term or min term must contain all input variables used in the expression. So that is each min term or max term must contain all variables. Are all literals. So these are the few basic definitions which must be known before we start designing any digital circuit.